Okay, today we're going to start the derivative application unit. So let's talk about these words. Relative max, relative min. That also could be known as a local max or min. It's just that you are going to be either higher or lower than the surrounding points. Okay, so let's talk about on this graph which one would be a relative or local max. So B is higher than points that are around it, and D is also a point that would be higher than surrounding points. Local or relative min. So A is lower than points that are close to it, and C is lower in comparison to points around it. Okay, and now an absolute max or an absolute min is it's the highest over the whole domain. So here B is an absolute max and A would be an absolute min. State the interval where the graph is increasing. So this graph would be increasing from A to B, and C to D, from C to D it would also be increasing. It is decreasing between B and C. Okay, so y prime is our slope. So if our slope is above 0, so the slope is positive, it would mean the function would be increasing. Right? It would be going that way. If our slope is below 0, right, so that would tell us that our slope is negative, our function would be decreasing. And if our slope is equal to 0, then we know that we are at some kind of min-max or critical point. So what does that look like? So if you get to something like a max and the tangent line would have a slope of 0. Okay, find the critical points, determine if they're min or max, and where this function is increasing, decreasing. Okay, so the first thing I'm going to do is derive this. So y prime equals 3x squared minus 12x minus 36. So I would like to now know, to have a critical point, I need to have a slope of 0. So how do I solve this? I'm going to factor it. Okay, so continuing to factor here, minus 6 plus 2, x equals 6, x equals negative 2. Okay, so I'm going to now draw a number line, and I'm going to analyze y prime. Okay, so I know at an x value of negative 2, y prime is 0. At an x value of 6, y prime is also 0. So now I'm going to pick something in this zone. So test a number such as negative 3. So I'm going to plug negative 3 in. I'm actually going to plug it into this line versus having to do it there. Because when I plug a negative 3 in, negative 3 minus 6 is negative. And negative 3 minus 2 is negative. So that would be positive. Okay, I'm going to test something in this zone. I'm going to test 0. 0 is on the number line there. So when you plug in 0, 0 minus 6, 0 plus 2, so that's negative, positive. So negative. And then here, I'm going to try something above 6. So 7. 7 minus 6 is positive. 7 plus 2 is positive. So this region is positive. Okay, so what does this tell me? it tells me my function is slope is positive, so it's increasing, and then a slope of 0, and then it's decreasing, slope of 0, and then increasing. Okay, so I now know increasing, it would be increasing from negative infinity to negative 2 with a round bracket, because specifically right at negative 2 you aren't increasing anymore. Also, so union, it's also increasing from 6 to infinity. It is decreasing over the interval of negative 2 to 6. Okay, find the critical points. So we haven't answered that. So we do know this. We do know that there's a max at negative 2 comma something, and I know there is a min at 6 comma something. Okay, so where do I go to find this? I actually have to go back up here, right? So here's a common mistake of accidentally plugging it in here. Okay, but I want to know the y value, not the y prime value. Okay, so I'm actually going to also just graph this in the calculator at the same time so we can see it. Okay, so let's just go to our table. So we can see we need to go pretty low. Negative 300 will go. Okay, so increasing max, decreasing min. Okay, so negative 2. So when we plug that in, we get 40, and then 6, negative 2, 16. Okay, and that's me plugging it in here. You're going to have to do that algebraically. Okay, find the critical points, determine if they're min-max, same kind of question. So we'll do it one more time. So y prime equals 2x plus 8. Okay, so where does this have a critical point? So that's where the slope is 0. So I'm going to move the 8 over, divide. Okay, so on a number line, let's analyze y prime. So all we have on our number line is 4. So we'll test something lower than that. So when I plug this in, negative 20 plus 8 is negative, and then something above negative 4, so this is positive. So my function is decreasing, and then it hits a critical point, and then it's increasing. Okay. We do know some things in our past that will also help us, right? Like this is a parabola, so I do know that shape. This was a cubic, so I know that it's going to make that kind of shape. Okay, so it's increasing from negative 4, right, to infinity. It's decreasing over this interval, so negative infinity to negative 4. And we have a minimum point, negative 4, comma, and then I plug in negative 4. So negative 4 squared, that's 8 times negative 4 plus 15 is what you're doing. And we get negative 1.